All right, here's another example of solving a system of irrational equations. If you think you can solve this by yourself, I encourage you to pause the video and try to solve it by yourself first, and then play the video and see how you did. So let's go ahead and solve this algebraically first. And we can do that again by basically setting these equal to each other. Now, technically, it's substitution. I'm putting this right here. So that's going to give me 5x over x plus 4 is equal to 2x minus 1 over x. An easy way to solve this is to form like denominators and then cancel those denominators out. So let's see. On the right hand side, the denominator has an x. So I'm going to need an x over here. By the way, let me just make this clear real quick. I can only put new factors in, meaning I can multiply. What I cannot do is put a plus 4 right here. This is a common mistake that some students will make. They'll think, well, I want them to be the same, so I can just put a plus 4 in the top and the bottom. No, you can't add something to the numerator and denominator and have it be the same. You can only multiply. So we'll have to do it like this and give this a factor of x to match this one. And if I put a new factor in the denominator, I need to put a new one in the numerator. Of course, this is x squared, so it'd be better to do it that way. And also, I will need an x plus 4 on the right. So I'll put an x plus 4 here, which is legal as long as I put a new factor of x plus 4 in the numerator as well. Now the denominators are the same, and I can cancel them out. By the way, maybe before I cancel them out, I should pay attention to the excluded values. X cannot equal 0 because of the x, and x cannot equal negative 4 because of the x plus 4. So let's just make sure that none of our answers turn out to be that. So back to business. I believe I was canceling these out. So that's going to give me 5x squared equals. Now I'm going to go ahead and double distribute this. 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. So that's 5x squared is equal to 2x squared plus 7x, all right, combining like terms, minus 4. Now, I'm trying to decide whether I should move all of these things over here to the left or whether I should move this over here to the right. The only reason why I would consider moving all this to the left is because I really want the leading coefficient to be positive. So it probably doesn't really matter, but I guess what I'll do is I will take two steps. So I will go ahead and subtract 5x squared from both sides. That's going to give me 0 is equal to negative 3x squared plus 7x minus 4. Hope you don't mind if I put this 0 on the right hand side. Just makes me feel better. But like I said, to be able to factor this and such, I would rather that the leading coefficient were positive. So I'm just going to divide everything by negative 1 now, which is legal. So that's going to give me 3x squared minus 7x plus 4 is equal to 0. Okay, now maybe this is factorable. I don't know, but I shall try. 3x squared would factor only as 3x times x. Now when I look at that 4, 4 could either be 2 times 2 or 1 times 4. I'll start with a 2 times 2. See how that goes. Inner plus outer must equal middle. Inner, I have 2x. Outer, I have 6x. That's going to make 8, not 7, so the 2 and the 2 is no good. Okay, so that was no good. So that leaves me with 1 times 4. Alright, I'm looking ahead a little bit. I know if I put the 4 here, that's going to make 12. So I'm going to go 4 times 1. Now inner, I have 4x. Outer, I have 3x. I can get a negative 7 out of this if both of these are negative, which means both of these would be negative. A negative times a negative is a positive for the positive 4, so this is working. To finish solving, I need to set these factors equal to 0. Alright, so that's going to give me 3x is equal to 4. So x is equal to 4 over 3. And from this equation, I get x is equal to 1. Alright, so I have these two x values. Now, remember, a key difference between simply solving an equation and solving a system of equations is that for a system of equations, you have not only x's but also y's. So these solutions will be ordered pairs with x's and y's. So I have these two x values, 4/3 and 1. Okay, I need to find the y values that go with them. By the way, are any of these excluded? No, so we're good. I could use either one of these equations to find my y values. So I think I'll just use the bottom one. Okay, so y is going to equal 2x minus 1 over x. Now I could plug these in manually. For example, with the number 1, I could do that pretty easily, because that would be 2 times 1 minus 1 over 1. So that would just be 2 minus 1 over 1. 2 minus 1 is 1, so that's 1 over 1, which is 1. Right? Just double checking. So this y value is going to be 1. So you can just plug these in by hand, but with 4 over 3, it's going to get a little messier. So now would be a good time to see what it looks like if you're using your calculator to help you out. So let's see, we have 2x minus 1 over x. So let's go into table mode. Alright, so we have 2x minus 1 over x. Right? Yes. Okay, I'm going to use Ask X mode to do this, especially since I have a fraction to deal with. So I have 4/3 I want to evaluate at 4/3. So I can just type in 4/3 like that. So the y value is 5/4. Okay, and just for fun, let's confirm what we did by hand by typing in a +1, and sure enough, it comes up with the number 1. So these are the solutions then. As ordered pairs, the solutions are 4 over 3, comma 5 over 4. That's one solution, and 1, comma 1. Alrighty then. So that's it. Alright, this is the solution to the system. Now let's just go back and take a quick peek graphically and see what this looks like. Alright, so let's use our phone as a graphing calculator. Okay, so you can either go to Desmos.com or you can use the Desmos app on your phone. Anyway, so our first equation is y equals 5x over x plus 4. So I'll just type that in. Y equals 5x over x plus 4. Okay, so let's see. It's a little bit hard to see. Let's see, can I make this a little smaller? Change the scale. Alright, that's pretty good. And our second equation is y equals 2x minus 1 over x. So y equals 2x minus 1 over x. So we see these two equations interacting, and they seem to have some intersection points here. So I'm going to just zoom in, take a closer look at what's going on there. So here are the 2 points where these points intersect. There's the point 1, comma 1, which is the point that we found. And this point 4 over 3, comma 5 over 4. Well, you know that 4 over 3 is 1.33, and 5 over 4 is 1.25. So what do you think we're going to find here? Oh, look, 1.33 and 1.25. So these are the two intersection points. This is what's happening graphically.